everyone, and welcome back to the channel. Today we have the most important video in the SQL injection series, and it covers a skill that I think is often overlooked or underprioritized when people are learning hacking and security. And that skill is how to fix the things we find. And more specifically for the SQL injection series, we're going to learn how to fix and how to mitigate SQL injection. This is extremely important when writing reports or talking to developers or talking to admins. We need to be able to intelligently discuss not just the problems that we found, but the solutions to those problems. I think the difference between mid-level and senior engineers or principal engineers is that the lower you are on that stack, the more you talk about problems, and the higher you are on that stack, the more you talk about solutions. So let's dive in and let's start talking about solutions. The first thing we're going to need to do is you will need to update the Git repo if you're following along in the labs. So we'll just do a Git pull. I'm already up to date because I've been working on it. The next thing we're going to need to do is I have updated some of the Docker files. So we're going to need to do a build as well. So we'll go into Docker, SQLi site, and we're going to do a Docker compose build. And that will just rebuild the images for you with the new files that have come down in the pull. Then we can do a Docker compose up -d. Now, when we talk about SQL injection mitigation, we're going to talk about things that we can do on the database side and things that we can do on the web application side, and both are important. The first thing we're going to talk about is authorization, and that's setting up users inside the database that can only do certain things or access certain things. And really what we're talking about is the concept of least privilege, and you probably hear that all the time, and you might even say it all the time, but we're actually going to practice what we preach here. So the first thing we're going to do here is we're going to take a look at the SQL startup script, and that's the script that's loaded up by the database the first time it runs to generate all that test data. And then there's a couple examples of different levels of users. So we're going to cd into the db directory. We're going to take a look at the dbsetup.sql. And this should look familiar. We did use this script in previous videos. Down here, we create a user called the web admin user, and this should be very familiar. We've used this in examples in the past, and this is also the main user that the web application we've been using authenticates as. And we can see that this user is granted all privileges on twebapp.star, as well as the database secrets.star. And what this means is this user is allowed to run any query on any table inside the twebapp database and on the secrets database. So far, we've really only been using one table, and that's been the directory table. So below this, underneath the creation of the table, and this is important, you can't grant privileges on a table that doesn't exist yet. So first we create the table, and then underneath, we create the user, directory user, identified by, and then this is a bad password, don't use a bad password, but identified by a password. And we're only granting select privileges, and we're only granting them on twebapp.directory. So this user cannot access any table other than the directory table on twebapp database. What this is going to do is, if we authenticate as this user, we can only select information from the directory table, and we can't union select to other more sensitive tables. So let's check this out on the database first. Docker exec ti, and that will be the SQLi site _db_1, and we're gonna come in as bin bash, and we'll MySQL u. And first we're gonna check out as the web admin user, and that user's password is admin_foobar. And here we can do a select star from twebapp.directory, and we can see all the data. We can do a select star from twebapp.users, and we can see all the data there too. But what happens if we authenticate as the directory user? And this will be user_foobar. So if we do a select star from twebapp.directory, we can see all the data. But if we do a select star from twebapp.users, we aren't allowed to access that information. So what does this look like on the website? Well, let's check this out. We'll go into our browser. I've set up a new page called lowpriv.php. So we're going to go to low-priv.php. And here we can run Alex and see that it comes back with the Alex information. But if we try and do a union select of username, password from users, we get 0 results. This doesn't stop us from doing a union select of the same table. So if we do a union select of lname and affiliation, which are 2 columns in this table from directory, we can actually get that other information. Now, this is information that's not generally seen by the web app or seen by the user of this page. So we are getting more information. What this means is that when we're using this authorization database protection, we need to make sure that we're not only designing the tables correctly, but the web app correctly and assigning correct permissions there. If this page should only ever see this information, then maybe there should be a table that only has this information in it. Just important to be aware that authorization doesn't stop the injection itself. It only limits what you can target. Another interesting protection that you can enact on the database is something called honey tables. You might already be familiar with the concept of honey tokens. Well, you can do something similar in databases with tables and database names. It's not a prevention so much as a high confidence detection, which is just as important when you're protecting environments. The usefulness of this technique comes from the fact that when you're working with databases, you're typically targeting specific data. You want this information from this database, from this table, and I want these columns. The only time people are bumbling through production databases and their infrastructure is when they don't actually know what that infrastructure looks like, and that's almost always going to be an attacker or a user that doesn't know the infrastructure well enough to be messing with it in production. So you can create tables and databases that look and sound interesting, but should never, ever, ever be accessed by a normal user, and just alert anytime that table gets accessed. So let's give an example here. Let's get back into the database and we'll come in as web admin. And the password for web admin is admin_foobar. And we're going to do a select star from secrets.topsecret. And we get some data back. Now, we've seen this database in previous videos, but what if this isn't real data? What if we just planted this fake data into the database so that if somebody stumbled across it, we could alert on it? Honey tables and honey databases can be anything. They can be called anything. But what's important is that we set up logging so that we can generate alerts when things like this are accessed. So if we hit exit, so in order to use a technique like this, the first thing you're going to need to do is make sure that query logging is turned on, and it should be for production environments, but just so you're aware of how this works, let's check out etc mysql conf.d. And in here, there's going to be a file called my.cnf, and this is just a common MySQL configuration file. So we'll go ahead and cat this. And we can see that we're setting up our general log file and we're pointing it at var log mysql query.log. And this query log is the log file that we're concerned with. So if we go to var log mysql and we cat query log, we can see that there is a log of all the different things that have happened inside of the database. And here we can see every single query that happened in our script even. So we can see we're dropping objects if they exist, and then we're creating those objects, creating our users, creating the tables, and inserting data into those tables. Down here at the bottom, we see these manual queries that we're running as part of this video. And we can see that we're selecting information about the top secret table in the secrets database. So what we can do is create an alert in whatever we're using for logging, whether that's an elk stack or Splunk, or if you have a SIM on the back end, you can have your SIM creating alerts if it sees logs like this. But we just want to see, anytime we see secrets.topsecret or top secret or secrets, those aren't real databases, those aren't real tables, and we want to generate an alert. And these are high confidence alerts. What I would recommend is put one of these in every database you have in a database server. So as the attacker iterates through every single table and every single database on the server, they're eventually going to trip over one of these honey databases or honey tables, and you can use that to alert on the fact that somebody is snooping around your database. Okay, so that finishes up the database end of our protections. Let's look at some things we can do on the web application end to mitigate SQL injection. The first web app mitigation that we're going to explore is using whatever your web language is to do the filtering. The first web app side mitigation that we'll explore is using the web app itself to create explicit filters in the logic of the application to block known bad types of input. Now, you can use whatever web application you want. I use PHP here because it's still a very popular web application language, but this same technique applies to any other web application language you can think of. We're starting out here in the Docker SQLite site web public HTML directory, and this is where all of the PHP files for the web application are kept. And the page that we're going to be looking at is the sorted-secure.php page. And you can see down towards the middle bottom of the screen here that we already have a filter set up. And what this filter is doing is looking for a space in the search term. And if a space is found, then it kills the rest of the processing with a message saying spaces are not allowed. This could very easily be any other string that you want, whether it's another character, such as a single quote or a dash, or it could be a full word like union or select or something like that. So if we check that out over here on the website, we can do Alex and we see that we get our return back. But if we try and do something sneaky like a union select, username, password from users, we see that spaces are not allowed. And here we enter the crux of the problem with explicit web filtering or explicit filtering in general. When we're trying to predict all of the different ways that attacks can happen, we will miss some or forget some. There's no way to exhaustively demonstrate every filter and bypass, which is kind of the problem with filters to begin with. But as an example here, we will carry out a bypass using comment characters, which generate a space inside of SQL. So we'll create this. These are multi-line comments, but we're not actually putting any comments in there. It just generates a space inside of SQL. Username, password from users. And we'll also use a different comment character here because the -- requires a space after it for the comments to work. And here we go. We've got our SQL injection with the username and password from users. Well, fine. What if we filter out single quotes? Well, this is a name field and people's names have apostrophes in them or single quotes or whatever you want to call them. What about filtering select? Well, people's names might have the string select in it. Well, what about space select space? Well, we can inject spaces with the comment character and a space won't show up in our search string, but will show up in the SQL. So this is one of these never-ending arms races. And to be completely fair, you can build really complex filter strings that can stop a large percentage of SQL injection attacks. The problem is all that needs to happen is an attacker needs to know just one additional way to run a SQL query, then you know how to stop, and then they're in. So this is just not a good way. It is not a comprehensive way of stopping SQL injection. That being said, if you have a really cool filter string that you're really proud of, or you're curious how a bypass would work, put it in the comments and let's have a discussion about it. The correct way to stop SQL injection and the way it is solved is through something called parameterized queries. And this is a section, if you have a buddy that's learning web application development at the same time you're learning hacking, send this section of the video to them because this is how we solve SQL injection. SQL injection is one of the few vulnerabilities that's actually solved. In fact, this section of this video is the entire reason that I wanted to make this entire SQL injection series. As cool as SQL injection is, it's something that we shouldn't be experiencing anymore due to parameterized queries. So let's check this out. We're going to go to secure.php. What a parameterized query is we prepare the query that we're going to run and tell the application whatever is here in this placeholder is only text. You should never consider anything inside of this placeholder SQL code. And then we bind the input field into that placeholder so that when we send it down to the database knows that anything in that input field should not be ran as SQL. We're going to look at the syntax in a second. Again, same as the last example, it will change depending on what language you're using. And some languages don't even allow you to build your own SQL statements anymore. They use an abstracted language for this. But if you are writing your own SQL statements, just Google your language parameterized query and figure out how it's done. It is not a huge refactor. I think this is the problem that a lot of people have with changing code to fix vulnerabilities, is there's huge refactors that can cause a lot of problems. But here I actually put in the original code and then the parameterized code. So the original query, the query that's being used in most of the other pages, is this 2-line. We create the SQL statement, and then we put the input field directly inside of that SQL statement as concatenated string. So we have one string that doesn't have anything special about any part of it, and we send that entire string down to the database. What we do for the parameterized query is that we prepare a SQL query. So we tell it that this is what the query should look like. Select fname email from directory where fname equals and then placeholder. This is specifically telling the database that this is what the query looks like. And anything that gets put into this placeholder is only text. And in fact, we specifically say when we bind the input field into this query that we're binding a string into that input field. So it knows that this is the query. This is just a string that's being searched for in the query or being added to the query. And then this is the query. And that's it. This is just an error correcting execution, but the SQL query doesn't run until we execute here. This is the equivalent version. So the extra step that's happening in parameterized queries is really this part right here. We prepare the query in the original example, and then we execute it. We prepare the query in the parameterized query example, then we bind the input, and then we execute it. There's 1 to 2 lines of code. Basically 2 lines of code turns into 4 or 5 lines of code. It's almost drop and replace. Let's take a look at how this works in the web app. So we'll go to secure.php and we'll type in Alex. We can see that the Alex information comes back. If we do something like union select username, password from users, we get 0 results because it's reading all of this as a string. It would be like if we searched for Alex double quote union select username, password from users. Basically, in this example, we're just using the wrong quotes to break out of that where clause. And since we don't actually break out of the where clause, it still interprets this as being inside of those quotes. It'd be just like that. The database treats all of this as if it's just text inside of that where clause. Since there's nobody named that, it doesn't return any results. Because we can handle any arbitrary input, this is exactly what we should be using. This allows us to have password fields that have single quotes and pound signs and ampersands inside of those passwords without worrying about SQL injection. This is what allows us to allow names from different parts of the world that may have characters that we're not used to seeing in them without worrying about SQL injection. Parameterized queries is the solution, and this is what we should be putting in our reports to help developers and help admins understand how to fix their web applications. So that's it. That's the end of the manual deep dive SQL videos. I'm super proud of you for sticking with it to the end. We have one more video in the series for SQL Map. So I know a lot of people are very excited about that. I know I've gotten a lot of questions. Hey, why aren't you teaching SQL Map? I'm going to, but it's important that we understood SQL injection from beginning to end, how SQL works, how SQL injection, the vulnerability comes out in a web application, how we take advantage of it as attackers, and then we can use tooling to automate and make our SQL injection more effective and more efficient. So I'll see you all in the next video, and thanks for hanging out with me.